So we were looking into the shift registers, right? And we had to discuss this serial in parallel out configuration, right? Um, yeah, just to recall, we had done the serial in parallel out shift register, and we had taken an example, and this is how your 4-bit register would look. You have your D flip flop, okay, which means you're sending your data input, and then you have to wait, you know, you have to wait till the data is passed from one register to another register. And when you take out lines from each flip flop, okay, that corresponds to Q0, Q1, Q2, and Q3 accordingly. Okay, so which means I am giving my input in this fashion, okay, and I am taking out my input in the format of parallel. So which means output is not available immediately, but then after clock cycles. So after clock cycles, that data will be available from one flip flop to another flip flop. Okay, so it moves on from one flip flop to another flip flop. So we have to wait for the data to get transmitted. One more thing that you can remember here is this is a D flip flop. So since it's a D flip flop, okay, so whatever is your input, the same thing is going to appear across your output, right? But only there is going to be a little bit of delay. So hence D flip flop, sometimes it's also called as delay flip flop, sometimes it's called as a data flip flop, right? Okay, so now moving on to the next concept, okay, where we had to discuss about uh, yes, so where we had to discuss this concept. Okay, so here you can see that you have a bubble at the front and at the back, so which means it is as good as a buffer. Can someone tell me what's a buffer? What's a buffer? Yes, buffer, something which has both input and output the same. Okay, so which means there is not going to be any changes towards the input and the output, but then there is going to be a slight delay, right? So whatever a signal that you are passing through here, okay, so uh, let's say for example, okay, you are passing a high value here, okay, and the same value, okay, since it gets inverted here and here also it gets inverted, so the same value appears here, okay. So which means when it's coming here, it is in the opposite form. It's in the opposite. That's why you have clock bar. So which means this is active low signal, right? What is active low? If you're giving the system responds to the opposite type of value. Normally the system responds to higher values, right? So here now the system responds to the opposite type of value. Students, are you getting what I'm trying to say? Yes. Yes, are you all able to understand? Yes or no?
Yes, sir.
Fine.
Yes, sir.
Okay. Right. So, so here for clock, clock is also a kind of a buffer, okay, because you have your inversion here, and then you have your the inversion also happening here, which means it is active low, right? So whatever signal that you pass through, okay, will getting here. So yeah, so that is fine. So clock is fine. Now there is one thing that we have to analyze here is, now if you see the notes that I've shared with you, right, the RS flip-flop, okay, the SR flip-flop. So if we invert the terminals, okay, if we invert the terminals, then it is as good as D flip-flop. It is as good as D flip flop. Okay, so you can just refer to my notes, and there uh, you will be able to find out the one in which I have converted. Okay, remember I have given a lecture about the conversion of flip flops, right? So in that I have listed out the equations, right? So there you'll be able to see that when we flip out S and R, then it is as good as a D flip flop. So this is the true value of the flip flop, and this is the complemented value of the flip flops. So it is as good as Q and Q bar. Okay, right. So, so the next thing, that you will be looking into is, so once the data is here, okay, it will keep passing. So here, since this is a parallel output, so the data gets passed from one flip-flop to another flip-flop, right? So consequently, I will have Q0, Q1, Q2, Q3, Q4, Q5, Q6, and Q7, right? So clock is again given all together, right? It has a common, sorry, this is clear, right? So if you want to clear out anything, then, it all happens in parallel, okay, right? So now you can look into the other information, which is nothing but clock. So clock also is given common, right? So I just have a single source of clock. I have a single source of clear. So any data here, I can clear it out. Now, serial inputs. How is it called serial inputs? Because I'm using an AND gate. As you all know, with AND gate, what happens? Multiplication happens, right? So multiplication happens with A and B, and then I have a single output here, right? Now here I have a bubble, here also I have a bubble, so which means it is a true value which enters. It's a true value, right? Say for example, after say I gave 1 here, and then I gave a 0 here, so what should my output be? What should my output be here?
1, sir.
1 into 0 is 0, so inversion 1. So again here there's an inversion, right? So what will happen? So the other
0.
value, yes, the other value will come. So ultimately what you should look at here is, okay, say I am giving two values here, but one value is coming out. So in this way I am able to achieve my serial inputs, okay. And the other thing, okay, the other thing that you can recall here is, there is another inversion that is happening, okay. So I am actually getting out my true value, which is 0, and you can either use A or B, okay. You can either use A or B, and ultimately the multiplication happens between them, and you will get one output. So whatever output you get here, okay, that is that gets transferred from flip-flop to flip-flop, and you have your serial input here with the help of NAND gate, okay. And because of that NAND gate, okay, you will actually be able to get your serial output. Serial output gets passed through the flip-flop, and then through flip-flop, as the clock gives its signal, it will pass from one to another. So consequently I will get my from Q0 to Q7. So I have achieved my serial input and I have achieved my parallel output. So data in is also achieved and data out is also achieved. So in order to get this complexity into a simple thing, okay, so what we do is we make a IC. So you will have just inputs A and B, okay, and then you will have your clear, clock, and then your outputs, okay. So this is using your SR flip-flop. Fine. Any doubts here? Can I proceed?
Yes, sir.
Fine. So this is our parallel in and serial out. So as I gave you a glimpse in the previous lecture, right? Parallel in, so which means I will get all the values inside one shot, okay, and then I will get my output bit by bit. The bits are entered simultaneously into the respective stages. Okay. The serial output appears bit by bit as per the clock pulse. So once I have one clock pulse, then I will get one value, another clock pulse, the next value comes in. To store 4 bits, we need one clock pulse because all are in parallel, right? To shift them out, we need another 3 clock pulses, which means 1 plus 3. So total 4 clock pulses for all the data to reflect at my output one by one. So this is nothing but called 4-bit parallel in serial out configuration. Okay, right. So let us see another configuration here. I had given a glimpse, right, in the previous class. Okay. So here it's going to be your 4-bit parallel in. Okay. So how is it achieving parallel in? Through D0, D1, D2, and D3. Okay. And serial out is achieved with the last flip-flop, with the fourth flip-flop. So Q3 will actually help us in getting out the serial data output. Okay. So here also, if I give higher value, okay, then it's going to shift. If I give a lower value, then it is going to load the value. Okay, it is going to load the value. So let's say I give 0, so this is going to get complemented, so which means all these are going to be high. This line is going to be high. So when this line is high, okay, so it will accept data from D0, D1, D2, D3. If in case this is low, okay, yeah, I've given 0 here. Okay, so when this turns 1, so which means this will also turn 1, 1, 1. So it is ready for accepting data D0, D1, D2, D3. If in case I give the other value, if I give 1, then this becomes 0. No matter whatever value you give for D1, D2, D3, what will happen? The output is always a 0 from here. I do not want that, right? So instead, what will happen? If I give a 1 here, then shifting operation will happen. So which means this line gets activated. Okay, and this line gets deactivated. This line gets deactivated, and this line gets activated. So I give a 1 here, so which means a shifting operation happens. So how is the shifting operation? How is it happening? Because the output is taken from here. So D naught I give, D naught comes, okay, gets into the flip flop. It comes out through Q naught. Once it comes into Q naught, it is getting into G4. Once it's into G4, then say this one is always a 0, isn't it? Why is it a 0? Because this line is inactive, isn't it? So if this is inactive, which means this is a 0. So 0 into anything is a 0. So which means ultimately my G1 is not considered. G4 will pass through the value. So 0 plus anything, it is not changing the value there, right? 0 plus anything doesn't change the value, but 1 plus anything will change the value. So since it's a 0, it's not going to change the value. G4's output will exactly come and it will enter my next flip-flop. Similarly here, this is also a 1, okay, so which means it will take my data from here. That data will pass through my OR gate, and from OR gate it passes through my register, and finally I will get my output across Q3. Any doubts here, students? Any doubts, please ask.
Sir,
Any
how
doubts?
do we select it? It's right shift or left shift, sir?
That's what, see, based on this inverter, right? Suppose I give a 1, then what is going to happen? This line will have 1. This line will have 1. Let me just, so if I give 1, then what will happen? This line will turn on. There is a 1 on that line, right? So if there is a 1 there, okay, so here what is going to happen? Here I will have a 0, isn't it? Yes or no? Yes, you're following?
Yes, sir.
Ah, So once I get a 0 here, then what will happen? Since it's a 0 here, okay, 0 and 0, my output is going to be water, always a 0. G1, G2, G3 will always give me a 0, no matter what you give here. So which means data is actually, not getting inside, even though you give D0, D1, D2 and D3, even though you give, what will happen? These will get nullified. D1, D2 and D3 will get nullified. Why? Because it's connected to an AND gate. D0 is not connected to AND gate. So only D0 will get inside. Understood? Right? So only D0 will get inside. So once this gets inside, now I have a 1 here. Since I have a 1, so which means either, let's say for example, the value is 1 here. So my output is going to be 1. If my value is 0 here, then my output is going to be 1 into 0 is 0. So if I have a 1 here, it is not affecting my data. Whatever is Q0, the same Q0 is coming across G4. So once it comes across G4, the same output is getting into my next flip-flop. Why same output? Because this is a 0. It is not disturbing my value of Q0. Understood? Yes?
Yes, sir.
Okay.
Yes, sir.
Now let's take the other case. Okay, just for you all to know. So let's take a 0 here. So if I take a 0, so this line is going to be red. Why is it going to be red? Because it's not active, right? So which means what is going to happen? My G4 is not functional, G5 is not functional, and G6 not functional. Not functional means what? I'm passing a 0 there. Since it's a 0, it's as good as not working, isn't it? So we have only G1 now, G2 and G3. Okay, right. So this line becomes active here for us. Since this line becomes active, okay, this line becomes active for us, right? So which means I have a 1, I have a 1 here, I have a 1 here, I have a 1 here. So once I have a 1, it will accept D1, D2 and D3. Okay, so which means D1 is coming here. Okay, D1 is coming here, D2 is coming here, and D3 is coming here. Yes or no? So D3 can be 0 or D3 can be 1, anything, whatever for that matter. So I have my values which is parallelly getting inside. So this is called load, because I am loading the values into flip-flops. D0 also gets inside. D1 is also getting inside via G1. D2 is getting inside via G2, and D3 is getting inside via G3, right? So via G3, it's making use of the OR gate. Okay, so OR gate plays a very important role here, and it passes the values and gets inside the clock, gets inside the flip-flop. So thereby, I am achieving 4-bit parallel. Okay, but the values will keep passing in the format of serial. Any doubts, students? Is it clear? Is this concept clear or any doubts?
Yes, sir.
Okay, fine. So, this is the concept that I wanted to teach you all today, and probably we will look into this. Okay, we will look into the waveform, and we will look into the other types of registers in our upcoming classes. Okay.